Algebra 2 students, this is a review of what we talked about yesterday with our factoring techniques. Remembering that step 1 will always be GCF, greatest common factor. Step 2 is going to be looking for perfect squared trinomials, difference of squares, and then our new ones, which would be sum of cubes and difference of cubes. So an example of sum of cubes here, obviously we've got the sum, and we've got two perfect cubes here. My first factor would be 2x, because 2 cubed is 8, and x cubed is x cubed, plus 5, because 5 cubed is 125. And then to get the next term, I'm going to square that first term, square that 2x to give me 4x squared. I'm going to multiply these together, which gives me 10x. And then I'm going to square the last term, which gives me 25. This will always be positive, and this sign is opposite of your first sign. And so that is complete. When we have difference of squares, we're basically using the same technique. What cubed is 216x cubed? It'd be 6x minus, what cubed is 343y cubed? That'd be 7y. And then that determines my next factor. So I'm going to square the 6x. I'm going to multiply these together. And I'm going to square the last term. That's always positive. This sign has to be opposite this initial sign. So that's factoring using sum and difference of cubes. So we can add that to our special list. Step 3 is if we've got 4 or more terms, we would use a technique called grouping. An example of grouping. Yesterday I did a few with 4 terms. This one actually has 6 terms. And you can do this several different ways, but if you look at these first 3 terms, they all have an a in them. If you take an a out, you'd be left with 3x plus 2y minus z. And then you look at the last 3 terms, they all have a b in them. And I'd be left with 3x plus 2y minus z. So once again, you can see what's in the parentheses is the same, so I'm taking that out. And I'm going to multiply that by the a plus b. And I have done that by grouping. That's the only method you can use when there are 4 or more terms. Now, after grouping, we've checked for all those special ones. Our only other option is trial and error. So the only thing we're going to do different in this lesson is that it may not actually be a quadratic, which means degree 2. It might be more than that. So we're talking about 4th degree polynomials here. We're going to do these in the form of a quadratic, which, if you remember, our first terms have to give us x to the 4th. So I would need x squared and x squared. Then I would look at my constant, positive 8, looking for factors of 8, 1 and 8, 2 and 4. But my outsides and insides need to give me a negative 6x squared. So I believe the 4 and 2 would work. This positive tells me that both signs must be negative. All right, and then we should look and see if we can do more. This first one looks like difference of perfect squares. I could factor that one to be x and x, minus 2 and plus 2. And then the x squared minus 2 is not difference of squares, so there's nothing I can do with that. And I would have that completely factored. This next example, again, my first terms need to give me x to the fourth. So I'm going to have x squared and x squared. My last terms need to give me 100. So factors of 100, 1 and 100. I don't think that's going to give me negative 29 anyway. Could have 2 and 50. I don't think that's going to work. 4 and 25. That might work. Both my signs need to be negative. And now looking at each of these individually, I think both of these are difference of squares. So I'd have x minus 2 times x plus 2. I'd have x minus 5 and x plus 5. And I would have factored that as completely as I can. Now, taking this one step further, if these were equations, let's say they were equations and they were set equal to 0, and I would ask you to solve this by factoring, we would do the same process. But now at this point, our solutions would be what makes this 0, which is a positive 2, which makes this 0, which is a negative 2, and what makes this 0. Now that one, we probably want to set this equal to 0. If we add 2, and then we would need to take the square root of both sides. And when we do that, remember you have the positive and a negative. So those would be your other two solutions there. This other example, if we have this equal to 0, and I was asked to solve this, my solutions would be positive 2, negative 2, positive 5, and negative 5. All right, so that's solving equations by factoring when they require a method called trial and error, and that the equations are in quadratic form. I'm going to include another video where I'm going to work out some of the problems in the skills practice.